Now we move on to selection sort. This comes after we have learned bubble sort and insertion sort. Okay, what we've learned in sorting so far is that basically there are different strategies to use for sorting. You can go from the very random one, like randomly opening a card to face up and then swapping them around to try to sort the correct order. However, this does not guarantee complete sorting, and more importantly, right, it might result in extra steps. Then, of course, you can do a systematic approach. Okay, but how do we choose the cards to review one at a time? But before that, let's do the unplug activity for selection sort first. So right now, you just need to focus on the slides on the screen. There's no need to use your laptop for this one. This is a one-player game. Objective to use selection sort to sort the cards in ascending orders, only revealing one card at any time. You can make use of 5 of the number cards that were given to you, okay, randomly arranged and facing down, and 2 objects like pens or erasers that will serve as a pointer or a demarcation tool. You can only choose one card to be faced at any point in time. You can pick at the cards one at a time. Cards can only be swapped. Once complete, get your tutor or classmate to check your method. But before we go into the actual unplug activity, let's look at how selection sort work first. So let's say I open up the first 2 cards here, 15 and 14. I will mark my demarcation between sorted and unsorted. Right now I see that on the left hand side is considered as sorted, right hand side is unsorted. So there are no cards on the left hand side right now. So the whole list is considered as unsorted. Then we will compare the first card 15 versus the rest of the cards one by one. So right now 14 is the smallest card, but as we go down the list and we open card by card, after you open 14 you can open the next one, and then we open the next one over here and realize that hey, the 4th card is at 10. So 10 currently is the smallest value. I will shift my pointer to 10. And I go down the list and open the 5th card and realize, oh, this is a value that's not smaller than 10. So that means 10 is the smallest value here. I will do a swap between 10 and 15. And once that is done, 10 is considered as sorted. So my demarcation can shift forward by 1. Okay, and the pointer for the smallest value will come back to the first unsorted value. You can try this process. You're trying to advance this demarcation pointer, each time trying to find the smallest value. Okay, and once your demarcation pointer reaches the end, you have completed your sorting. Alright, for this period of time, please focus on this activity first. Let your friends check. Okay, let's look at carefully at what selection sort is right now. Let's say I have a list again. The whole aim of this selection sort is to do this, is to select the smallest element in the list and swap it with the leftmost unsorted element. Okay, after I've done the swap, that smallest element is considered as sorted. So now let's look at the first line of this unsorted list. I have 8, 5, 7, 1, 9, 3. 8 is highlighted in green. This is the current leftmost unsorted. Alright, I go down the list. I find the smallest element. Right now is 1. So I do a swap between 8 and 1. So 1 will go to the first position and then 8 will go to the 4th position. Okay, once I've done that, 1 becomes sorted. Okay, then I do the same. Now the next unsorted, the leftmost unsorted element is 5. 5, I go down the list, I look for the next, the smallest element, which is 3. 3 will swap with 5, and now 1 and 3 are considered as sorted. So you run down this whole process and you can see that the sorted element grows bigger and bigger and bigger until eventually the entire list is considered as sorted. So just to show this process, so right now 5 is being compared with the rest of the list and 1 is the smallest. So 1 will swap with 5. Alright, now with 1 is sorted, we're comparing 2 against the rest of them to find the smallest. And in this case, 2 is the smallest too, so 2 will not be swapped. Moving on, we are looking at 4 now. 4, 6, 5, 3. Smallest in this list is obviously 3. So 3 will swap with 4. Okay, next we are comparing 6, 5 and 4. And the smallest in the list is 4. So 4 will swap with 6. And now we have 5 and 6. Okay, it looks done, but actually you realize the code will continue to compare first. Alright, so this is how your selection sort is done. Alright, let's move on. Is selection sort in place? Okay, what exactly is in place, right? Remember, in place means that I do not create any extra memory space for this. Okay, if let's say my list at first currently has 6 items, Okay, I do not create an extra list. I do not create extra items to hold one of the elements as a temporary place. So selection sort, we can see that we are just doing a mutual sort within the list itself. So we are mutating the list as we go. We are not creating a new list. So we are not creating any additional memory space. Okay, so of course this is considered as an in-place sort. Okay, is selection sort stable? What exactly is stable? Let's say there's a case where there are repeated elements within an unsorted list. So let's say that I have two threes here, one the red and the blue one. A stable sort will give you a result that the red 3 will still come before the blue one, and the unstable one might reverse the process. So you have a 3, the blue one will come ahead. So this depends on the implementation of the sort. But let's look at how selection sort does this, right? Okay, if we quickly look at this one over here, let's say my list is now 4, 5, 3, 2, 4, 1. Okay, and there's a yellow 4 and a blue 4. Again, I go down this list, I look for the smallest element, which is 1. So 1 will be shifted and yellow 4 will be shifted to the back. Now I go down this list again. Now 1 is sorted 5, 3, 2, 4, 4. 2 is the smallest element, so 2 will be sorted with 5. And then of course we go through the whole selection process and realize that now the yellow 4 is actually at the back of the blue 4. So this is a non-stable process. Alright, so this is something you need to take note for selection sort. If you need a stable sort, selection sort is not the way forward. So we'll learn next year that it's actually possible to do a stable selection sort as well. Order of growth for selection sort. In this case here, right, best case is O(n) squared. Because you look at this, it will make a pass of, you will look at the first row, you will compare 5 elements, then 4, 3, 2, and 1. So basically, you have a sum of AP. Average case is also O(n) squared. Worst case is also O(n) squared. Okay, why is this the same? Because, okay, if you look carefully at this, right, if you go back to the previous slide here, regardless of whether the list is sorted or not, right, this selection sort will complete the entire process. It will run down until you have the last element sorted. So regardless of whether the list is sorted, it will still do the check. Okay, as you can see in the animation that was done earlier. Alright, that's all for selection sort. You can move on to the rest of the LTE questions.